Let's start a quick revision for the alcohol, phenol, and ether. Okay. So first question: arrange the following in the increasing order of the boiling point. First, pentan 1-ol, butan 1-ol, then butan 2-ol, then ethanol, propan 1-ol, methanol. Greater surface area, greater is the boiling point, and branching decreases the surface area and decreases the van der Waals force of attraction and decreases the boiling point as well. So pentan 1-ol is the greater surface area, highest, then butan 1-ol, then in butan 2-ol it is the third last. Why? Because it is in the third point, because from butan 1-ol to butan 2-ol there is a branching taking place. Okay, then propan 1-ol, then ethanol, and then the smallest one methanol. Second one is given. Second one is also boiling point, increasing order of boiling point, or arranging the order of boiling point. Pentan 1-ol, in butane, pentanal, ethoxyethane. Very important question. See, any all is always having the higher boiling point due to intermolecular hydrogen bonding, so it is in the first. Then it will be al, because al having dipole dipole interaction. So okay, then second will be the al, and then ethoxy. In the ethoxy compound there is a oxygen is there, and whatever the thing is happening because of the oxygen, so little bit higher than then n-butane. N-butane doesn't have anything. So first will be all because of intermolecular hydrogen bonding. Al will be the second because of dipole-dipole interaction. Ethoxy, there is oxygen in the middle. So whatever the thing is happening because of that oxygen, so little bit higher than the normal straight chain. Next and very important question for CVSC and ISC. This is C2H5ONA CH3 CH3Cl, and this is the product given. What would be the major product of this reaction? See, I have told many times here it is a Cl is a leaving group. He wants to leave. When it is Na plus O minus, O minus is a nucleophile, so he wants to approach here and throw the Cl out, but that thing is not possible because of a 3 alkyl group and huge repulsion between them. So when this nucleophile, negative charge nucleophile, will going to approach to the carbon, there will be huge repulsion. That is why this reaction, this substitution does not occur. So what will be the product then? Then product will be here, this negative will come to take the hydrogen from here, make the double bond and throw the Cl out. Like this in the here, this is taking the hydrogen, make the double bond, throw the Cl out. And so if this C2H5O minus take the hydrogen, so it will be C2H5OH. Later Cl going out, combining with Na, forming NaCl, and this is the compound after the elimination of the hydrogen, and it will be double bond will form. So this will be the compound. So next question is asked that what will be the suitable mechanism or suitable reaction for the preparation of tertiary ethyl ether. This is the tertiary compound. So tertiary ethyl ether, that means what will be the actually if I want to prepare this one, so what will be the suitable method? Okay, the suitable method will be opposite. If I take CH3CH2ONA and then plus CH3CH2Cl, then this negative, this nucleophile can approach to the carbon and throw the Cl out. Then this reaction is possible, otherwise not. Again, I am repeating. This question is given. Okay, they are telling this is the reaction, then they are telling what will be the major product of this reaction. Cl is a living group, he wants to leave, nucleophile can approach to the carbon, but he cannot approach. Why? Because of 3 alkyl group, there is huge repulsion between them. This substitution not occur. So what will occur? The thing that will occur will be the negative will take the hydrogen, make the double bond, so the Cl double bond will occur. What will be the side product? This C2H5O minus taking the hydrogen, so it will be C2H5OH, and then plus NaCl, the side product. If I, next question, if I want to prepare this, so what will be the suitable method? The suitable method will be opposite. If I take CH3C, CH3ONA, and if I take CH3, CH2Cl, this negative will attack to the carbon, throw the Cl out, so this thing will occur, plus NaCl. Okay, next, moving on to the next question. Now next question is also very interesting for the CVSC and ISC format. It's very important. Show how the following alcohols can be prepared. Now when, see this one, how will you prepare these two? So when the CH2OH group will be there, so always it should be HCHO, and you have to prepare using Grignard reagent. So in the Grignard, one should be MgBr, another will be the aldehyde or ketone. So when you see that the CH2OH group is there, that will be always HCHO, and the remaining part you give MgBr. That is a trick, not a mechanism. Here if you see CH2OH group is there, so you put it HCHO, and the remaining part you give as a MgBr. So I have given this remaining part CH3, CH3, MgBr, and then this one HCHO. So if I give this one, then you know very well that is, it is positive, it will be negative, negative will attack to the C, open the bond. So this CH3 CH3 link with that CH2 bond will be OMGBr. Upon hydrolysis, this OMGBr will be OH, and eliminating product will be MgOHBr. That will be the side product. Okay, same here also, the CH2 group is there, so it will be one thing will be SCHO, and the remaining portion you can only cyclohexane is there, so I'll add cyclohexane with MgBr. Same, it will react to the CO group, open the bond, so CO will be added to the CH2, and then OMGBr. Upon hydrolysis, MgOHBr will be the product, and this OMGBr will be OH, so it will be CH2. So in this way we can do. Next question, it is phenol to anisole. Anisole is benzene with OCH3 is called anisole. Phenol is this one. So I am giving NOH first. NOH is the base, which will take the hydrogen from here. So it will be, water will be eliminated, it will be ONA. Then we are giving CH2Br. So ONA means O plus Na plus O minus. So O minus take the methyl group and throw the ClBr out. So it will be OCH3, which is the anisole. Next is aniline to phenol. It's a very important conversion, aniline to phenol. Aniline to phenol, we have to digitize first. So that is why we are giving NaNO2 HCl 0 to 5 degrees centigrade. Actually, if normally we tell in the ISC, if the conversion in the two step, you give the side product to the balancing. It is easier. So here, if you do the digitization, you will see NaNO2 plus 2 HCl. So NaNO2 plus, and side product will be always be NaCl, and it is minus NaCl, that means going on liberating, and minus H2O, that means those side products are liberating. So Na2 plus 2 HCl, and 0 to 5 degree, it is being Na plus N2 plus Cl minus, and the element which is act as a side product, that means going out, that is minus NaCl, it is also a side product. H2O is also a side, 2H2O is also a side product. So I am writing minus NaCl. That minus doesn't mean anything, those are the side products. Side product we write as a minus. Okay, so NaCl is one side product, 2H2 is a side product, we are writing minus, that means they are eliminating. Okay, after forming the N2 plus here, we are giving water. So if you give water, it will be OH, and then this N2 is the side product, and then H and Cl combine to form HCl. So this is aniline to phenol. First digitization with NaNO2 plus 2 HCl 0 to 5 degrees centigrade. Side product NaCl and 2H2O minus hybrid, N2 plus Cl minus, then water, and greater than 5 degrees centigrade, and it will be OH, N2 and HCl, the side product. Next question, formic acid reacts to the Tollens reagent, but acetic acid is not, because in the formic acid there is a CHO group. Formic acid HCOOH is the reagent. HCOOH is the formic acid. So because formic acid contain hydrogen attached to the CO, because in HCHO COOH, this is a formic acid, CHO group is there. So that means CHO group is there, that is why it can reduce Tollens reagent, but acetic acid does not have. That is why it is told hydrogen is attached with the CO group, hence it can act as a aldehyde, so therefore it can act as a reducing agent. That means it can reduce Tollens reagent and give the white precipitate, but acetic acid is not. Next is why benzoic acid does not undergo Friedel-Crafts reaction. For the Friedel-Crafts reaction, benzene should be electron rich. Benzene should be electron rich, but if it's a benzoic acid, COOH group, COOH group is the electron withdrawing group. It deactivates the ring. That means, as because NO2 group is electron withdrawing, so it will withdraw electron from the benzene ring. As a result, Friedel-Crafts reaction will not occur, because Friedel-Crafts reaction need electron rich substance, not electron deficient substance. That is why it is written that due to deactivation of the benzene ring, in the withdrawing effect of the COOH and AlCl3 bonded with the COOH, these are the two major reasons. Due to that, the Friedel-Crafts reaction cannot occur by the benzoic acid, because COOH group is the electron withdrawing group, so it will deactivate the ring. But Friedel-Crafts reactions normally occur with the electron rich rings. That means who donate electrons, but not with those which withdraw electrons. Okay, next is ester hydrolysis is slow in the beginning and become faster after some time. Actually, in the ester hydrolysis, it is an ester, water, and concentrated ester were given, and a small amount of dilute ester were added in the beginning to start the reaction. Initially, if you give small ester, small amount, so reaction started. As the reaction proceeds, is when the COOH is start to prepare enough amount is start to prepare, then the reaction becomes speeded up. Okay, initially you are giving just to initiate the reaction, we are giving concentrated sulfuric acid here. Now when the reaction started and this acid start to form, the reaction becomes faster. Okay, So that is why in the beginning it is slow, but later on it is become faster. So when a small amount of H2SO4 is added in the beginning to start the reaction, as the reaction proceed, ROH is formed. As the amount of ROH proceed increase, so the reaction becomes increases. Initially it is slow, but when ROH start to form faster, so reaction will also become faster. So here too, this question is very important. The why benzoic acid does not undergo Friedel reaction, because benzoic acid contains COH, which is a electron, which is deactivating groups, which withdraw electron from the benzene ring. So it deactivates the ring. That is why it's not possible. And next, because Friedel reaction needs electron-rich substance. Next, ester hydrolysis is slow in the beginning, because when you are giving consider dilute sulfuric acid or concentrated sulfuric acid, when you are giving, it's a little bit amount. So it just start the reaction. Then when RCW start to form much more extent, so reaction become much more faster. Moving on to the next question. The next question is arrange the compound with the increasing order of boiling point. See here, COH is there. COH form dimer. Dimer means its size will be bigger. So that means its melting point, boiling point will be higher. So as because acetic acid is there, so they are giving three compound. Here one aldehyde, acid and alcohol. We know alcohol go for hydrogen bonding, okay, but here as because acid forms dimer, so it has the highest. Then is alcohol because of the intermolecular hydrogen bonding, and last one will be the aldehyde. As because acid form dimer, so it's become bigger. So that is why its melting point and its boiling point will be higher than alcohol. Alcohol form intermolecular hydrogen bonding, and then aldehyde. Next is why benzoic acid is less soluble in water than acetic acid. It's also very good question. That benzoic acid is both are polar. Benzoic acid and acetic acid both are polar, so both can form hydrogen bond with water. Both can form hydrogen bond. But the problem is in the large hydrocarbon chain of benzoic acid. If you see the benzoic acid should be benzene and COOH. So due to the large hydrocarbon part, the extent of hydrogen bonding will be much more less because of the large hydrocarbon part. That is why extent of hydrogen bonding will be less in case of benzoic acid. That is why benzoic acid will be less soluble. So I repeat the question again. Why benzoic acid is less soluble in water than acetic acid? Because benzoic acid and acetic acid both can hydrogen form with water, but as because it is a big benzene ring is there, it's called large hydrocarbon part is there. That is why it is not able to form much hydrogen bond to a much extent, and so that is why benzoic acid will be less soluble than acetic acid. Next question is MgBr with the CO2 and H2O plus, then PCl5A and B identification. When you see that carbon dioxide is given to the any of the Grignard reagent where the MgBr is there, you put COOH there. So if you see the Grignard reagent is there and then they are giving carbon dioxide and H2O plus, so which part of where the MgBr is there, you put COOH. Here I put it COOH, PCl5 is there, PCl5 nothing else, in place of OH Cl will come. So the product will be CH3COCl. Moving on to the next question. Next question, I am given some structure and the products like that. If you take CH3CH H plus by water, it's an Markovitch reaction. Water will be broken down to the H plus OH minus. OH minus will go to that carbon which contain less number of hydrogen to the double bond. So here you can see, here I have given CH3 CH double bond CH2. If I break it, water will be H plus OH minus. OH minus is the negative part. It will go to that carbon which contain less number of hydrogen. So here it is hydrogen is less, so OH will go there, hydrogen will be go this side. Okay, next question is here. This is also a very important question I am giving. So this is here, you can see it is a 3 alkyl group is that, so it will be 3 degree. So always if you have this kind of question that one side is 3 degree, one side is 1 degree, so I minus, here HI means H plus I minus, so negative parts always go with the 3 degree carbon and hydrogen will go to the opposite one. So I will go with the 3 degree here. So one product will be CH3 whole thrice Ci, hydrogen will come here over here, so it will be C2H5OH. If it is a 3 degree or benzyl also same thing happen. So you can see is over here. Here is a benzyl. Benzene with CH2 means benzyl. So if you give HI, so it will be H plus I minus. I minus will go to the benzyl one. That means it will be benzene CH2I. Because benzyl carbocation is resonance stabilized, so I minus will come over here, H will come in there. So it will be benzene CH2I and CH3OH. Okay, so here this thing will happen in the 3 degree carbon. If you see that one part is one part of the ether is 3 degree, another part is 1 degree, so I minus will go to the 3 degree and H will go to the opposite. So the product will be CH3 whole thrice I and C2H5OH. Here is also benzene with CH2, that means benzyl carbocation is there, benzyl is there. So I minus will go to the benzyl carbocation and H will go opposite side, will be CH3OH. And then here you can see benzene with OC2H5, OC2H5, OC2H5 is the electron donating group. That means it will donate the electron through resonance. That is mean it is activated ring. So NO2 group will come into the ortho and para position as because it is activating ring. So as because of resonance, oxygen have lone pair of electron control resonance. That is why its ring is become activated. So NO2 group will come in the ortho and para position. Dilute H2SO4 is means water is there. So you write one side H, another side OH and break it. So it's a very simple dilute H2SO4, one side H, on other side OH and then break it. So it will form CH3 CH2OH, CH2 CH2OH from the both side with the dilute H2SO4. Next, phenol with acidic anhydride and the C2H5OH acidic anhydride. We have told many times acidic anhydride is written like that, CH3O CO CH3. Then we are taking one part as a Cl. This is we are taking one part as a Cl. Then we'll take this hydrogen and the thing which one we are taking as a Cl. So this is will go. This will form acidic acid CH3CO and H. CH3COOH will form, and the product will be remaining here O and here COCH3. So the product will be benzene OCOCH3 and this one CH3CO. Again I am telling this acidic anhydride, we are opening the molecule CH3COO, COCH3, OCOCH3 part we are taking Cl. So hydrogen and this Cl, HCl will go, that means acidic acid will form CH3COOH. And the remaining is OCOCH3. So it will be benzene OCOCH3 plus CH3COOH. So in this way we do. Next, balance chemical, give the balance chemical equation. Balance chemical equation is very important in the organic reactions. You have to write the full equation. Phenol is to the neutral FeCl3. 6 C6H5OH plus FeCl3. So FeOC6H5 whole 6 3 minus plus 3H plus 3HCl. Just let me explain. The iron valence C3, it will replace 3 hydrogen, but 3 hydrogen does not exist. Actually hydrogen is 6 because hydrogen exists as H2. So I have given 6. So iron forcefully have to take the 6 C6H5O. He has taken FeOC6H5O whole 6. That means normally is valence C3. But here taken 3 extra, that is why 3 minus is given. Okay, then here 6 hydrogen is there. Out of that 6 hydrogen, 3 is used up to form 3HCl. 3 is remaining as a 3H plus. Again I am taking iron will replace 3 hydrogen, but 3 hydrogen does not, actually hydrogen is 6, so I am writing 6 C6H5OH, but iron have forced to take the 6 molecule of that, so it will be FeOC6H5 whole 6 3 minus. Okay, done. 3 minus. Why? Because his valence is 3, but he have taken 6. 3 extra is given, so 3 minus. Then remaining one 6 hydrogen are there. Out of that 3 hydrogen combined with 3 Cl forming 3 HCl. 3 is liberating, so 3H plus. Then next is question is phenol is treated with the chloroform. Oh no. Phenol with the chloroform is a very important question. Remartiment reaction, phenol with chloroform, remartiment. I will suggest those are preparing for ISC and CBSC. Please go the balance chemical equation. Phenol CHCl3 plus 3NOH, OHCHO plus 3NaCl plus 2H2O. Next, anisole is treated with the HI. Anisole is benzene is OCH3. If you give HI, just above oxygen, give hydrogen I and break it in this way. So it will be phenol plus CH3I. Phenol plus CH3. Phenol treated with the bromine water, it's a very important. Phenol and bromine water, you should take 3 molecule of Br2 and water, so it will be tribromophenol plus 3HBr will form. So those are the name reaction, those are the questions, balance chemical equations. After this I will go away to the next video, the next revision.